And now we get it to limits more algebraically speaking and working with limits at infinity um, and figuring out how they work algebraically. So here on the screen are just some quick examples that you should be able to more or less get through in about 10 to 30 seconds. Okay, so I want you to pause the video, try these on your own, and resume the video when you're ready. And here are the answers, okay? Most of these you should have a picture in your mind for the graph. So like, y equals x, 1 over x, right? So it's, down here like that, and then up here. And then these, higher degree, right? They're going to, like 1 over x squared does, up and up, something like that, near 0. So then all of those would have a similar behavior, right? So sometimes you get lucky and things are simple. Sometimes you're not so lucky and you're going to have, examples or limits where it's like infinity minus infinity, 0 over 0, plus or minus infinity over plus or minus infinity, infinity times 0. So what do you do? Our first example is like, well, yeah, so if I think about this in the back of my brain, this is just me thinking, right? This is like infinity minus infinity, right? If I were to do them each alone, okay? So our limit laws don't work at infinity. So what do we do? Answer is algebra, but maybe there's also a more clever example. So if we factor this is x times x minus 1, right? So we know it's a parabola. It has zeros at 1 and 0, so it looks something like this, right? So if I can imagine what the graph looks like and say, oh, okay, well, in this case, by its end behavior, because that's really what limit as x approaches infinity is asking for, it's just infinity, okay? And so using a graph might help. Other instances is like, well, I could graph it without, so when I say graph, I'm trying to use a graph without the assistance of a graphing utility, Desmos, calculator, etc., right? If I can quickly generate the graph, that could work as justification. But in other cases like this one, where you have a square root, that isn't so easy to envision, right? But when I'm thinking about it again, right, it's like square root of negative infinity squared, more or less, and then plus a negative infinity is kind of what I'm thinking about, right? So at the end of the day, it's kind of like infinity minus infinity, and so is that just 0 or not? Okay, and so how do we work through that? Okay, best best way I can suggest is with algebra and trying to, since it has a square root in it, multiply by the conjugate. So we multiply by square root of x squared plus x plus 1, and then minus x to numerator and denominator. X squared plus x plus 1, all minus x. And then I'm just going to tell you that this eventually simplifies to, you can double check this on your own, limit as x approaches infinity of x plus 1 in the numerator. Denominator is still that square root of x squared plus x plus 1, and then minus x. Okay? And then now, this is okay, and this should be minus infinity. Now what I'm going to do, because I know how to work personally better with limits at positive infinity rather than negative infinity. So what I'm going to do is I'm going to do a little substitution. I'm going to do let y equal negative x. Okay? Then what I get is that limit as y approaches positive infinity, right, because I do a substitution of negative x, this would give me in the numerator negative y, because I had positive x, and then plus 1 over square root of y squared minus y plus 1, and then plus y. Okay? And now what do I do? How do I go further? Okay? What I'm going to do is I'm going to multiply by 1 over y times 1 over y. Okay? Why did I pick this? I want to multiply by, so I want to multiply in the denominator to both numerator and denominator by the highest degree monomial appearing in my entire expression. Okay, why isn't it y squared? Well, y squared's under a square root, so if I were to square root y squared, it'd be like something to the first power. Okay, so that's why I'm just doing 1 over y. And when I do that, I get limit as y approaches infinity of -1 plus 1 over y all over square root of 1 minus 1 over y minus, or plus 1 over y squared, and then all plus 1. Okay, why is that helpful? Because up here, right, I know that these ones, if it's 1 over something, those all have limit 0. So at the end of the day, when I do the limits, this is going to go to 0, this is going to go to 0, this is going to go to 0. So then what am I left with? I'm left with -1 in the numerator, and then 1 plus 1 is 2. And I get 1/2, -1/2 for my answer. Okay. So that works. Okay, so try some algebra, multiply by a conjugate. Next example you see, it's a rational function, right? We don't have to worry about the conjugate here, but you still look at this and you're like, well, I don't know how to attack this algebraically. I might have some ideas, which I'll verify in an informal way later. But what I'm going to do is kind of repeat this trick where not trick, but the strategy of multiplying by the highest degree monomial to numerator and denominator. So what I want to do is multiply by 1 over x squared times 1 over x squared to every single term. And what I get is limit as x approaches infinity of 4 over x plus 2 over x squared minus 3 all over 2 plus 3 over x minus 1 over x squared. And then lots of things go to 0. Okay, and I'm left with -3 over 2. Okay, and based on your knowledge of rational functions, you're like, well, I already knew that there was like a horizontal asymptote at -3 over 2, and limit as x goes to infinity is just looking for the horizontal asymptote. Is that enough? No. Okay, we want to use calculus methods, right? So go through and do this algebra and use the limit idea, okay? You can certainly check, right? You can check using other methods. For example, one way that I personally check is just to say that, for x really large, that just means much greater than 0, right? We can approximate this limit by saying limit as x goes to infinity of -3 over x squared over just 2x squared. So eventually, for large values of x, the highest powers will dominate, and then we get -3/2 another way, but that's a checking way, right? So I don't want you to use that as a way to just find the answer. You can use it to check, not to find, all right? So couple other things to be aware of as we work with limits and limits involving infinity.